Hello and welcome to another episode of Fun Times in Statistics. I'll be your host. Today we're going to be doing some stuff on Minitab Express. Specifically, we are going to be doing the chi-square test for independence two different ways. First of all, we're going to be looking at some smoking data that we've used previously in the semester. But I'm not going to use it the way we have before, where I had the actual data in front of me. I have a summary table of information about that data. In particular, we're going to be looking at, do the genders seem to have different behavior when it comes to activity level and exercise? More specifically, I want to know, are these two related? So how we're going to formulate hypotheses for that is I'm going to be comparing my two different variables here. Be careful, your variables are activity and gender. The choices for gender of male and female, those are categories within the categorical variable of gender. A lot, moderate, and slight are categories within the activity variable. So what I'm going to be investigating is activity level independent of gender. So I'm asking myself independent, so that means they have no relationship with each other. They have no effect. Is another way to think about it. And then the alternative is just the opposite. So if the null hypothesis is about how they have no effect on each other, then the is going to be the opposite. So activity level, wow, I made that huge for some reason. Let's make it more like a normal sized thing. Failure. Not independent of gender. So this is saying they have a relationship, which is interesting. Okay, so now I need to input my data into Minitab, and this is something you have to do very carefully when it comes to copying in a table. Now, if your copy doesn't go so well, you can just type the table into Minitab, and the part I'm highlighting right now is the part you will copy. So notice I'm not going to grab that upper heading of activity. If there were any total columns, like somebody had added up all the allots, all the moderates, all the slights, or all the genders for each of them and gave you a total column, you're not going to need that either. Minitab's going to calculate the totals for you, and actually including the totals can screw you up. So notice I am just clicked anywhere where there isn't stuff already, and I'm at the top of a heading of a column, so not in row 1 where the headings go, actually, and then I'm going to try to paste it. And if you've done this correctly, it should recognize that this first variable that it's got is gender, and that should be a text or a categorical variable, and then the rest should be recognized as quantitative. And then what I'm going to be doing next when it comes to doing the chi-square test is hoping that Minitab will recognize this for me, or at least communicating to Minitab that that's what I'm doing. So to do that, I'm going to go to Tables, Cross Tabulation, and chi-square. Notice this top option is raw data, as in your variables are just in two columns and it needs to make the row and columns itself to make its own table. We don't have that. We have a two-way table that we've entered in. So I'm going to change this drop-down menu to summarize data in a two-way table. So it's going to ask you, where are the stuff that has your data? Well, it's in C5, C6, and C7. And then it asks you, do you want to include your optional row variables? I suggest you always do this. That's that gender variable that's going to help make your rows. So notice gender goes down the rows because it'll make it easier. Otherwise, Minitab's just going to call them 1 and 2, and you're going to have to guess who 1 and 2 is. And if you have a lot of them, it's just easier if you use the name. Okay, next up we need to tell Minitab what we want in our output, and you're going to do that by clicking on Display. Here's where we're going to have to be careful. It will not do the chi-square test without you telling it to, so you make sure you check this box. You're also going to want the expected counts. That's what's in step 3. I want the expected count table. I'm also going to ask for its contributions to chi, because that will tell me who's the significant contributors, just like it did for the goodness of fit test. Once you have all these checked, you can check some of the others if you want to. I'm not going to need them for anything, so I'm not going to. Let's be okay. Or let's click OK. That was a fun mistake. Okay, so in reading these this table can be kind of difficult. One cell has 3 items in it, so these 3 numbers represent both a lot and male in 3 different ways. So the first number is going to be count, the second number is expected count, and the last one is contributions to chi. So I'm going to have to read off this table the values for expecteds by grabbing some of those. So for the male and a lot expected, that's 8.08. See where I'm getting that number from? Moderate, 23.46. And then for slight, we have, 3.46. And I said for a reason. Give that one a highlight because we're going to come back to that. It's important. Let's finish this up first. 12.9, was it 4 or 2? 2. And then 37.54. And then last but not leastly, 5.54. So I've filled out the expected values table. This is a typical kind of question you're going to see on Minitab or on my stat lab or in your homework, and asking you to fill out what are the expected counts. And Minitab will do it for you. You can make this do more decimal places if you want. If you remember from the video, to do these kinds of calculations, what you would have to have done was taken the total from the row and column that box was in and then divide it by the overall total. So it saves you doing, well, 6 calculations for this one, but it might save you for more on larger ones. Let's find the chi-squared test statistic. Now Minitab 18 and Minitab Express both give you 2 chi-squareds. We are using the Pearson chi, so our test statistic, is 2.49. How many degrees of freedom are there? I'm going to show you how to do this by hand real quick, and then you'll notice that it matches the degrees of freedom that's being reported in the chi-square test. So to do the degrees of freedom, you're going to do the number of rows minus 1, so 2 minus 1, times the number of columns minus 1, which for us there's 3 columns, minus 1. And then you'll notice that's just 1 times 3, or sorry, times 2, which is just 2. Subtraction. It's a fun thing. Now, I have one more thing I need to go back and do. I haven't dealt with this highlight yet, so let's hit enter. I did not want that to happen. Sorry about that. I wanted to put it before step 4, which it's probably going to leave me a little weird space. Now make yourself like whatever symbol will draw your attention, like right here, and make it like huge and expensive and whatever it is that draws your attention to something. So one of the problems we have here is that we have an expected count that's below 5. Which means we really can't use the chi-square test results from this test because, well, it doesn't meet the conditions for using the chi-square test. One of the requirements for the chi-square test is that all of your expected values have to be at least 5, otherwise the values might be so small that it can't detect the differences as they exist. So what's the problem with this is, I have failed to meet the conditions for using the test. And these only matter in the expected values, so you're going to have to calculate the expecteds to see if this is going to happen. So unfortunately the slight male group is too small. I don't have enough here for me to be able to detect differences using the chi-square test. I'm going to do the test anyway, as I've already done, because I need to show you some examples, but you need to watch out for this. Now Minitab will also notice this for you, so notice down at the very, very bottom of the test it says, hey, one of your cells has an expected count of less than 5. That means you really shouldn't use these results or be cautious about using them because, well, you didn't meet all the conditions. The fix to this is usually to draw a bigger sample so that you are more able to test and determine if things are different or not. That being said, let's move on and finish this test. So yeah, here we go. Let's find our p-value. The p-value for the Pearson likelihood test is 0.2883, which we note is much bigger than 5%. Our cutoff value for alpha. So in particular, here we are going to fail to reject the null hypothesis because, as it appears, yeah, I got too big of a P. So as you look at this, it's highly probable that this is not an unusual sample compared to our original hypotheses. So I would say there is no difference here, or as we would say, actually this is not a difference test, this is a test of independence. So it would appear that these two are independent of each other. So gender and, sorry, let's write this. The evidence suggests that gender and activity level have no effect on each other. aka they are independent. Voila. The biggest thing about this is saying that, oh yeah, knowing somebody's gender doesn't tell me if they are more active or less active, or the other way to think about it is knowing somebody's activity level, I cannot predict their gender because they have no relationship with each other, which makes sense. I mean, this is one you probably would have suspected wouldn't be independent, but remember, we want to have evidence to support our anecdote rather than just going with anecdote, because one of those is much stronger than the other. All right. And now on to an example. So this is taken from a book that is not our textbook. It's by Vare and Sharp, and I listed the page number to cite this from. This is from a court case where they were looking at whether or not there was some racial steering. So if you know what racial steering is, it's when real estate agents or agents of sale try to steer people of specific races towards certain areas so that they are all housed together rather than mixing races. This is something that's very inappropriate. So we're going to use their data to detect some racial steering. So they did some sampling of tenants from two different housing sections. So they divided it into two pieces, section A and section B. And we want to see, does housing section, is it independent of race or not? Because if it isn't, that's a bad thing. Clearly we have evidence of racial steering. And that's what our null and alternative hypothesis are going to reflect. So housing section is independent of, race. And then the alternative is the opposite. So we're going to have that housing section is not independent of race. I know some of you, it's probably going to bother you that I've capitalized certain words. I tend to capitalize things that are variables, and I also capitalize not to draw your attention to it. Now, looking at our data, you notice we have race and housing section and them in just their own separate columns. So that means to do both the observed and the expected tables, I am going to need to do some counting, and I'm going to let Minitab do that counting for me when it does its cross tabulation. I'm just putting this on a new page so it's all on one page. Sorry about that. Cool. So once again, we're going to go up to tables. We're going to select the cross tabulation and chi-squared menu. Now this time I have raw data. As you look at the data, I have section going on to make my rows. So that's where I'm going to put housing section or C2. And then my columns are made by race. So I'm going to click on C1, double click to place it in my columns. As always, we're going to click on display to make Minitab do the counts for us. So here I go. I'm going to make it do a chi-square. I want expected cells, and I want contributions to chi so I can see where the greatest differences are. Let's go ahead and hit OK. Beautiful. So notice the first value in our cells are going to be the counts. That means that that's my observed values, the ones that were actually counted from the two variables themselves. So that means for section A and black, I have 8. For white, I have 87. And then for section B, for black, I have 34 and 83. I'm hoping you're seeing where I'm getting these values from. So those are some differences, and one section appears to be bigger than the other. That's interesting. Okay, well, chi will account for that size difference as well when it comes to doing its observes minus expected, and then you divide by the expecteds to make sure you account for size. Okay, so 18.82 for section A. For the white section, 76.18. And then for section B, 23.18, and then 93.82. Let's see what we have. So then in looking at the Pearson chi, my chi-square test statistic, oops, I usually do these in red so they're more noticeable to you guys. Sorry about that. Is going to be 14.06. That's not very big, but also look at our degrees of freedom. It's only 1 because we have a 2 by 2. Let's just write df equals. Make that red and big like we usually do so we can notice it. Yeah. And then we're going to find the p-value. Let's see, and that's 0.0002. Pretty small. So small. Oh, it's less than 5%. You know what that means? It's time to reject the hoe. Sorry, time to reject the null hypothesis. Well, that's a bad thing, because what that's telling us is that, yeah, they're not independent. It appears that race and housing section are related, which means there is evidence of racial steering, and it's exactly why they lost that court case. Lots of people getting sued because racism shouldn't be happening. So, there is significant evidence that housing section is related to race. So I'm going to add into this not independent, just so it's clear for you guys. Okay, cool. So now we have a little bit of a problem. Going back and reopening, actually let me make similar to reopen this. One of the things that you will notice if you are going on to do anything in market research is that we have a little bit less we can do with Minitab Express. So I have a section here on Kramer's V. We don't do Kramer's V in our class in Statistics 2. It's not part of the required content of that course. However, for those of you who are taking market research, you may be asked to calculate the value of Kramer's V or measure for association. If that is the case, make sure you make friends with somebody who has a PC, because the PC will do it, but this will not. It's just how it is. I believe there might be a way for me to make it happen. No, it's only got 2 options. Okay. Well, that's unfortunate. So I was very certain you couldn't do Kramer's V on Minitab Express, but you can do it on Minitab 18. So as long as one person in your group has a PC, you should be okay. They can watch the same video that we have here on how to do it on a PC, and then you can actually calculate the values of Kramer's V. And I have a description of what Kramer's V tells you here so that you can use that in your report. And that's all I've got for you. I hope you enjoyed this episode, and my birds didn't sound too loud through the whole thing, but who knows?